Example 4 in the factorial section. Write this expression. That should say write. Write the expression using factorial notation. So we have 12 times 11 times 10 divided by 5 times 4 times 3 times 2 times 1. So we want to work backwards here to figure out what we have. Hopefully you can see that in our denominator, right away, we have a 5 factorial. 5 times 4 times 3 times 2 times 1. That's 5 factorial. Now, in our numerator, all right, this certainly looks like the start of a factorial, but then it abruptly ends. So here, really, we should be looking at what's missing. What's missing? Hopefully you see that, well, if we started with 12, that this was originally a 12 factorial. And that is equal to 12 times 11 times 10 times 9 times 8 ... times 1. So you see that it's this piece here that has been cut off, right? So we can rewrite that as 12 times 11 times 10 times a 9 factorial, and that captures the end there, right? That captures all of those numbers from 9 to 1. And we see that in our problem, that's what's been canceled out. So how can we add the 9 factorial in even though we know it's been canceled? Well, what if we put a 9 factorial in both the numerator and the denominator? It's not going to change. It's not going to change what we started with here, but it does allow us to write this whole thing as a factorial. So if we in the numerator change this to 12 factorial, or why don't I just say 12 times 11 times 10 times 9 factorial, then in our denominator, we'll add in a 9 factorial. Okay, and now let's just combine what's in our numerator here, this 12 times 11 times 10 times 9 factorial. Let's just combine all of that to be a 12 factorial divided by, and we'll write these from largest to greatest, divided by 9 factorial times 5 factorial. And we know if we went back the other way, we would see what cancels out, and you'd get back to the original problem.